I will guide it, facilitate it, but it's everybody come learn about this. And I will try and get the technical people to sit there and say, I want critical feedback on what it is I'm doing. Okay? And what I will coach the team to do is constructive criticism. And I will try and coach the team. If we're going to do a code review, it's all about learning. It's all about safe learning. It's about how do we do this better. Some teams, they don't like that. They've got long-standing battles and such, and I will try to get away from that and then go maybe to some peer review. So how do we do code review in such a way that two people who can work well together will sit from time to time and say, before I check this in, make sure that nothing's fallen through the cracks. What have I missed? What didn't I think about? Well, let's come up with a little handy-dandy checklist. Just says, did you name your variables correctly? What are the things we want to make sure don't fall through the cracks every time I check the code? And that's sort of like, 2 eyes are better than one, right? Copilot checks the...
I think you mean 2 heads are better than
2 heads are better than one, yes. It's 4 eyes are better than 2?
Yes, sir.
I like to mix those metaphors.
Assuming we're not on the Odyssey.
The key to peer code review is to get people who really can work. And then pair programming, oftentimes for things that are really difficult, 2 people building it together is almost like having design sessions at the same time you're writing the code. And I will say, if you're creating a calculation engine or you're creating some heart of the system, you'll want to do that interactively. And that's the type of code review I usually go out there and talk about. The formal analysis is definitely necessary. If you are building software to control the flight system of a 777, you need to know that plane is not going to crash. If you're building something for medical systems, you need to not make sure it doesn't give a lethal dose or whatever it is. Those things require formal methods. Don't get me wrong. My understanding is that when they were building the software for the flight controls on the space shuttle, maybe it's the space shuttle, they had like 30 QA people for every programmer. They wanted to make sure that
it was a ridiculous testing process.
Yeah,
yes.
ridiculous, right? But it was warranted, right?
Yes.
These are vehicle safety systems. When I came out of university, I went to work for a company that was making airbag sensors, and these things, crash sensors. These things tell the vehicle safety system you've been in a crash. Well, apparently false positives are a problem because the airbag goes off. But when it doesn't go off and you've been in a crash, well, that's even a bigger problem. So it has to detect when the crash has occurred, and it has to detect it within the right thresholds and all of those types of things. And we would test everything. It was just QA. Well, it turns out at that company, it was a division of TRW, they had another group not too far away that was making something called the nuke switch. And see, the nuke switch tells you when your nuclear warhead has been launched. And apparently having one of those things go off at the wrong time is a really big problem. So whatever we were doing from the quality perspective was nothing compared to it. We were like 6 Sigma, they were like 9 Sigma or whatever, 12 Sigma. But they put these nuke switches on a missile, a warhead, and when that warhead experiences like 9 Gs along some radial axis, they go off, right? But if the warhead falls off a truck, it doesn't go off. So it's arming this warhead depending on whether it's been launched or not. So it's almost, this was a technology, almost the same technology that they put in the Porsches and the Legends. So my point in all of this is that you want to do formal methods when you're talking about mission critical life systems, those types of things. But I've never done quality the same as I did when I was working on the vehicle safety systems. Because usually I'm not doing something that involves life and death. Any other questions?
I don't know if this fits into this talk or not, but I think the problem that I've had with organization I'm on for the last year and a half or so, there is knowledge that the developers and the senior development staff and the management around that are very knowledgeable about best practices, and they give strong lip service to it. But when it comes down to actually charging time, implementing best practices, suddenly there's no charge code for it.
Yeah, yeah, sure.
Stamps.
Couple of quick examples. I mean, we had a wonderful lunch and learn on style cop as a way to keep our coding style consistent.
Mm-hmm.
Of course, we have millions of lines of legacy code, and one of the questions I asked, hey, what do we do about legacy code? And he said, well, between projects, don't do it while you're working on something that has to be, but between projects, that would be a good time to draw a line, go through, whatever application that is.
Right.
We have scores of applications. It's not just one website, it's lots of them, and make the change there. So I came to that point in the project that I had worked on, and I told my boss, well, I ran style cop. I have 10,000 changes that I have to make. It's going to take me, I estimate, 4 or 5 days to grind through every one of them. Most of them were really small. And there was just no way to do it. And I could go through the same examples in testing and automated deployments and the whole thing.
Sure.
I mean, it's just, when it comes down to it, there's no charge code. What do you suggest?
What's your tolerance for getting fired?
I have high tolerance on this. I'll do it. Give me an idea.
Dare me.
Just do it and charge it overhead? Because that'll do it.
This ain't his first rodeo.
I have encountered this problem many times. And I think the first thing is you've got to make the right judgment call as to where you're going to do the investment. I worked on a project a few years back, and it had been going on as a consultant maybe 2-3 years ago. And I came into the project, and the project had gone for 3 years, failed to launch, was in a 6-month reprieve, and if it didn't launch by the end of February, it was going to go to, it was going to go terminal. And I joined the project in November. So when I joined the project in November, so we've got, 5 months to take this 3-year project and make it launch. And the technical lead brought everybody together, and I was just a consultant brought in to be a developer, one of the developers. And we sat down and we listened to this technical lead basically say, we're all going to die. Get your resumes, dust them off, go find another job. You're not going to see me for the next few months. And true to his word, he was gone early January, first week of January he was gone. But he basically said, we're all going to die. So after he left the room, we literally didn't see him until his goodbye party. But I brought the team together and I go, we're not all going to die. We're going to do something about this. We're going to go down with this ship. And what I decided to do was look into the unit testing that they had written. And most of the unit testing would say, test method name, it was all C# code, it would have open curly bracket, return true, closed curly bracket, and a whole bunch of commented out statements in between. And so there were lots of tests, but the vast majority of them would just return true. So what I decided to do was I decided to start writing lots of tests. And I think in a 1 month period, I probably wrote about 400 automated integration tests. And I wrote the tests all around the most complex code. But nobody told me to do this, and I started finding bugs all over the place. Because as you start writing tests, you start finding bugs. The other thing I did was I went over and I said, let's look at the defects. And we had this stack of defects. I mean, it was quite a big thing. It was all electronically, but I printed it all out on paper, so I could have page numbers. And I had a table like this, and I started creating piles with the business analysts. And we had a pile over here called, defects. And we went through, and we started putting them out. Some of the defects would read something like, wouldn't it be nice if the system would do X? Right? And I said, that's not a defect, that's a query. So we started creating new piles, and there would be defects that would run contrary to the requirement. So the requirement would say go clockwise, and this would say go counterclockwise. So we created like all these piles. And then we came down and we had this list of what would ultimately be called true defects, and we separated those out into the ones that were visible, highly visible, and those things nobody would see, and we started. Ultimately, we went back to the developers, and I said, only work on these. I said, these are the ones you'd be embarrassed that at the end of February, these weren't fixed, you weren't good software engineers. I said, all the other ones over here, we're going to go and we're going to defend. We're going to go to the mat, and we're going to say, you're not going to ship the system because this thing that says, wouldn't it be great if the system could do X hasn't been fixed? Right? So what we were going to do is we're going to take management to task, fix everything that would be, because what was happening was they were finding the one defect and saying, look, you guys didn't fix X, right? And then they were ascribing that same problem. So that was one of the practices I went through, which was sorting the shinola from the other stuff, right? And then the automated testing. And I think we got to somewhere in the low 80s on the code coverage, which was just one way of measuring that. There was, if anybody knows cyclomatic complexity, there was one area called, that had a number of 361. And for those code complexity, anything over 20 is usually considered unmaintainable. Anything over 30 is unmaintainable, those ranges. This had a 361. It turns out a lot of the bugs were coming from as a matter of fact, I learned on the internet, according to Abraham Lincoln, like 68% of your defects come from the most complicated code. It's just, we started to find things by doing static code analysis and automated testing, and by the end of February, it's all good to go. Now, if somebody had said, what code did you write, C# code did you write in that period of time, I could only point to the test code. I wrote no production code, zero production code. I asked the team to fix the bugs because I didn't know anything about the production code. So I made an investment. I could have got fired for that. Like, hey, you were here to fix bugs, not to be writing test code. You were here to be writing C# code. That's what you were hired for. Not to triage bugs.
Not to lead the team.
I was certainly not hired to lead the team. But when Captain Doom decided to disavow himself in front of the team,
We created a vacuum.
I thought maybe I would do that. So some of it is just, you got to try the intuition. I think if I had spent time on StyleCop, I probably would have been taken out and shot, figuratively, of course.
Well, I mean, a lot of us said, we have a lot more serious problems here than coding style. I mean, that was one of the reasons why that lunch and learn by one of the senior mugging bucks just kind of got laughed at. But, I mean, a lot of that has been going on, and we're just not making any progress in best practices. We're just kind of spinning our wheels on it.
One bug that I found through automated testing has been a story I've told. I was sitting at my desk, and this is the same project, and the developer comes up to me and says, "There's something wrong with the test suite." And I said, "What do you mean?" He said, it's failing this test, but I just changed one line of code." And I said, "Okay, well, let me see the line of code." And I looked at the line of code, and I was like, I don't see anything wrong with the line of code. Let me go back to my desk. It's got to be something wrong with the test. So I'm looking at the test, and this voice inside of me said, "Steven, it's not the test. The test has been running fine for weeks now. It's not the test." So I said, "Okay, it's not the test. Let's run the test." So I just ran it locally. I got the latest, ran it locally, and I had this error appear called Stack Overflow. Right? And I'm like, Stack Overflow? I've heard that somewhere before. And so I looked into it, and the change he had made was that in the code that cleared the cache, it was calling, it was a very subtle thing, it was calling a base class which was causing a recursive call, and so he had a recursive loop that was causing this thing. Now, he and I resolved this problem in 5 minutes without having to talk to anybody about it, right? As soon as I showed him, I said, "You're supposed to be calling this, not base dot blah, you're supposed to be calling this dot blah," or whatever it was. And as soon as he saw it, he's like, "Oh, yeah." Right? We were just like, and I was thinking, test saved my life today. Well, I was thinking it saved his life, but then I thought to myself, let's think about this. We go and we push this out to the QA test environment, and every now and again, the server just goes, right? And we're like, nothing we did last week changed this, right? We didn't do it. What did we do, right? And there would be, what were the steps to reproduce that? And they would say, "Well, we were just doing this." And then it would happen again, and it'd always be something different. And there'd be nothing we did, there'd be nothing they did. And the two of us resolved that problem in 5 minutes, right? But just think of the nightmare for years to come. Like, just my grandchildren could be working on that system, and they could be fighting over the phantom crashing of the bug, because it would clear the cache just like at this time, and it would, when it cleared the cache, it would just go boom. And those are the types of things that automated testing. I worked on a federal civilian client, and I started doing automated testing on that client. And they had a Spanish language website they were rolling out. And through the automated testing, I found that they spelled the name of the federal agency improperly in Spanish. There was a misspelling in the title of the page. So they were going to roll it out in Los Angeles. And
the testing tested the name of the page?
the testing had only one spelling. So if I tested anything, where I would go and look at the title of the page or whatever. So one of the things that I did was I said, hey, when this page loads, I'll know it's loaded properly because the name of the thing will be the name of the agency will be in the page, right? And so it turns out that this thing had two parts to it. It had a WordPress part and it had another part of it, you know. And so in one part it was not spelled correctly, right? So it would load the page and it would say fail. I'm like, fail? I can see, you know, Selenium just loaded this page. It looks great. Fail. And then I dug into it. Like, oh, you don't spell that word, you know, that way. And so they found that. Now, it suddenly dawned on me that none of the developers knew how to speak Spanish. Right? So they're not going to know the correct spelling. And, you know, was it a requirements error? Is it reasonable to expect this? But my automated testing is like the Terminator, right? You couldn't bargain with it. You couldn't plead with it. It was going to insist that it be spelled right every time. And it found this problem, and it found many other similar problems because it was methodical. And sometimes problems can only be found if you take it methodically. Those are the types of things I usually tell management, is I give them these examples. It's like, you know, what do you want to do? You want to have your developers sit there not being able to perceive problems and fight with one another over things like these caching problems? I have seen teams fight with one another. Hammer and Tom, you know. QA's quality perception of what the programmer has built is that it's crap. They give me crap. They throw the crap over the wall. I have to deal with this. You know, and if it's not working, then the quality integrity isn't there. And the developers are like, they keep writing these bugs and they never give me enough information to go find them. What does that mean? It just crashed. It just crashed? What does that mean? Must have been something they were doing. No, it's this crash because of the recursive error in the cache, clearing the cache. So they're going to fight about that for years to come. So those are the types of things I try and tell management as to why you do best practices. You change the whole tenor and tone of the organization. But sometimes management isn't always like interested in that fundamental, you know, change in spirit. You know, they're invested in a little bit the way things are and incrementalism, you know, features and other things like that.
They have a bias.
They do have a bias, and it's not a guaranteed payout, right?
Well, I think a lot of the software also is not being continuously upgraded and improved. It's software that got written once for a particular purpose. It takes data from this queue.
It's the Golden Gate Bridge. It was built, right? We're going to paint it. We're going to remove rusty
It
sections.
sits on the shelf and then it never gets changed. But that's not true. It does get changed eventually.
That's right.
Somebody has to go in and fix it.
I'm looking for the counter argument, by the way. Something that is constantly renewed and remade. Right? The Golden Gate Bridge, like, is an O&M. It's like the typical O&M thing, right? For another 100 years, it's going to sit there, and they're going to have an operations team maintaining it forever. But most software doesn't work that way, right? Most software
Sandcastle.
is more like a sandcastle.
That's awesome.
But it's constantly being rebuilt, right? It's going to start all over again. And most developers are like, as soon as you're done, it's like, let's plow it under and let's plant, you know, something completely different. They want to do something different with it. I mean, 5-6 years is okay, but it's like now it's just old and bogus. Let's redo it. And so much management is like, let's build a 30-year software application.
Isn't that banking?
And that's
Aren't they still on COBOL or whatever that thing's called?
Sure, yes.
Yeah.
I worked as a contractor for a bank who was going through their third attempt to replace their core accounting system, which was written back in the 60s. This was back in the 90s. They tried a small talk implementation with IBM. That had failed. They had tried something with another company. At that time, Arthur Anderson was going through the same change to Accenture, and they were currently working on the project. I don't know if it ever succeeded. I was working in another department, but the big iron was everywhere. This is why I sort of think of software as sort of biological in the company. It accretes, it grows, it spreads. You could try to plan as much as you want, but the fact of the matter is it's going to take on a life of its own at some point. I mean, there were parts of the accounting system they did not have the source code for. They knew the inputs and outputs were right, but that's all they knew. And there were these amazing piles of software on either side dealing with the output of the accounting system. Just because it's like, well, we can't actually change this, but we can play with the streams on either side of it. It was quite the beast.
Yeah. It's amazing what some of those do have biases behind them. I mean, people are averse to change, and sometimes they're self-fulfilling prophecies. I was working on a project in the early 90s, and the project was based on DOS, and it was doing its it screened stuff to something called the Targa board, and I don't know if anybody here remembers the Targa board, but it was basically a card on the PC. And there was a reluctance to go with Windows on this software system. And it was really because the owner of the company, the founder, president, CEO, really didn't get why people wanted to get off DOS and go to Windows. And he just didn't get it, right? And I have a very low tolerance for getting fired. So I went to the CFO and I brought him over to our inventory room and I said, see those boxes of DOS 6.2? We have stockpiled DOS because Microsoft isn't going to be supporting DOS anymore. And when all those boxes run out, we won't be able to sell any more new systems. That is your future, right? Do your financial planning around that. Right? And the CFO was like, what? It's like, I have a fiduciary responsibility to go talk to the board about this. And I said, oh, do you? I hadn't realized that before we did this little tour. And apparently, they got the Windows program started not soon after. We had an interesting debate about the future of 16-bit versus 32-bit Windows.
God.
But anyway, the point I'm trying to make is that I think some of those things are self-fulfilling sometimes.
Sometimes they are.
And that has really been one of the... We were going to stay on DOS for a long, long time. It was just going to happen because I don't get this Windows. Why do we need Windows?
Why do you see two things at once?
Who needs any more than 640K RAM?
That's right.
Stephen, we're getting close to the top of the hour. Have you thought about how you want to?
We can do the raffle any number of different ways. Let's see.
You've got index cards or paper.